Good afternoon, everyone, and welcome to the Fall 2025 seminar series hosted by the graduate student community at GCOE at OU. First, a little bit about the GSC leadership team for the academic year 2025-26. We have Rodney and Samuel as our co-chairs leading. Swapnil and I handle the publicity for all our events. We have Siavash as our treasurer, and we have a youth support team uh, consisting of our past and current members from Zareen, Lewis, Roshan, Rachel, Anshu, Nurayan, and Mohammad Sadiqur. We all work cohesively under our mentor, Professor Farooq Mistri. We have our regular meetings, the leadership meeting on Thursdays at 4:30 p.m. We host these meetings on Zoom. So if you want to join, please contact Samuel or Rodney. Their emails are here, and we can adjust the time as per uh, the members attending the meeting. To become a GSC at GCOE member on Engage, you can just scan this QR code. So just scan this QR code and log in with your OU ID, and you can become a member. It's as easy as that. We do have our LinkedIn page where we keep updating about all the events or stuff we are doing. So do take a look at it. Then just scan the QR code again for the LinkedIn. Also, we promote all of our events on Facebook and Instagram, so you can follow those pages as well to keep in loop of whatever events we are hosting. And finally, we have our YouTube page where we upload all of our webinar or seminars and that we host. So the, if you miss some talk you want to listen to, you can go and check out the YouTube page. Uh, we do have a team room called the Dave and Susan Bird team room for the GSC members. It has all the basic amenities you need to just relax and hang out in a place, or you can do your own work. So if you need access to that room, you can email us. You can email Rodney or Samuel. We can provide you with the access. Gentle reminder, as Farooq told, a sign-in sheet would be a link for the sign-in sheet would be provided. Please do fill out that. That helps us in keeping track of the attendance for each of our talks. So please do fill out that. So this year's or this semester's theme is exploring research frontiers with generative AI, the issues, methods, and applications associated with it. So we are exploring how generative AI is reshaping research, industry, and society. But like, how do we use it responsibly? So through this fall GSC seminar series, we will be bringing leading voices from academia and industry to explore that. And we are seeking or featuring speakers who can address one or more of the following themes. The first one is how people can work with generative AI to create intellectual, economic, and social value and connect these domains. Second is research issues, methods, and applications that arise when people collaborate across research, industry, and community. And the third and final is ways for people to design generative AI initiatives that link academic inquiry, economic innovation, and social benefit in ethical and equitable ways. So all the webinars will be around this theme. So with that, today our first speaker for the Fall 2025 series is Professor Vistasp M.Karbhari. who will be talking on generative AI as an enabler for learning. Uh, Vistasp is a visionary leader in higher education and a distinguished scholar in and both civil engineering and mechanical and aerospace engineering. He has served as the eighth president of the University of Texas Arlington. Uh, Under his leadership, they attained the Carnegie R1 status. Professor Karbhari research is equally impressive. He is recognized internationally for his pioneering work in mechanics and processing of advanced composites, durability of materials, and infrastructure resilience. He has also had the accolade of fellowship in American Association for the Advancement of Science, National Academy of Inventors, and many more. And just as importantly, Professor Karbhari is a dedicated advocate for leveraging digital transformation and innovative pathways for student success, always centering around the mission of higher education as a driver for opportunity and societal advancement. So it's a pleasure to host Professor Vistasp. And with that, Professor Vistasp, the platform is yours.
Thank you
Thank you.
very much, Avinash, and thank you, Farokh, for inviting me to speak. Let me just take a second to make sure that I can share with you all. Wonderful. So when Farokh asked me to speak on this topic, he also told me that I would be the kickoff speaker. And I made a choice, and I hope my choice was the correct one. If not, my apologies, Farokh. I decided to go broad rather than deep. I decided to look at the general issues that are ahead of us, especially not for those of us with white hair, but for those like the graduate students who are in the audience today, because this will be a tool, this will be a focus of how they will work, how they will interact, how they will live in society and in academia. And so I wanted to talk a little bit more about the issues than going deep into anything or talking about a very specific AI tool or model. And so I started off by saying, let's look at GenAI as an enabler for learning. And I want to be very, very frank up front. I took assistance from AI for the images that I'm going to use. Both of them came from DALL-E and from ChatGPT. I tend to use those extensively, and it has definitely changed the way in which we work. Things that, as you might remember, so Farokh, years ago, when we actually put together images, we sent them to a person on campus who made a slide for us. If you remember the Diazo slides, and then we put them together in a carousel, very carefully carried the carousel with us. And that took weeks, if not months, depending on the queue. So we had to have the presentation done weeks ahead. And of course, when we were flying from one spot to the other, once in a while, security would want to see it and they'd change the order of all the slides, or one would drop out and then we'd have a problem. That has changed completely with AI, where we can now do a lot of this by ourselves. We are, and I call it an education enterprise because the university as we know it has changed over the past 20 years. Knowledge is increasingly complex. It is increasingly interdisciplinary. It's very difficult to look at knowledge in a very siloed way, and we shouldn't be looking at it that way. Our traditional teaching modes have struggled to keep pace with technological advances. And the gap between the academic knowledge and skills, and I use the word skills in a very broad sense. It's not only working with hands, but it's how we actually stay in the workplace to be relevant, both as entrepreneurs and as people working for others. Those necessary for success in the workforce are actually widening. Research is being transformed from what it used to be at a university, from an area of discovery to now being a revenue generator and a rank builder, with consequent pressures on faculty, staff, and students. If you look at headlines from all across the world, it doesn't matter where you look at it. It's basically going to say that AI is either coming for your job or it's going to change your job significantly. It's changing the workplace itself, and therefore one has to ask questions. What does AI do, and what are the changes likely to take place in this educational enterprise and then the workforce behind it? My apologies to those who are from a non-engineering field. I will generally not be talking about engineering, but I am going to use engineering as the context because that's my background. We will be transitioning from groups and teams of entry-level engineers using codes, handbooks, computer programs, to smaller groups of experienced decision makers, letting AI platforms then do a lot of the what if and the initial designs. The engineer then becomes the overall decision maker rather than the subdomain expert, which completely changes, if you will, what engineering education is supposed to be all about. We'll be using aspects such as drones, sensors, digital twins, and simulations, and these might very often replace field personnel. The focus, therefore, if you use AI the right way, should not only be on enhancing productivity, but on enabling new and complex approaches with increased efficiency and multiple options. So when I talk about AI, I look at it as something that is able to support, to enable, to enhance, and to expand, not to replace. But we do have to ask this question of ourselves, and I'm going to pose this in the beginning just for all the academics in the room. If we do not change significantly, are a significant percentage of our degrees aimed at positions that could eventually be replaced? Most of our bachelor's degrees are for entry-level positions. If you look at it from a very basic viewpoint, those are the positions that could actually be taken by AI. You look at a design engineer, and most of the designs that the design engineer will come up with are going to be things that are very easily automated and looked at by AI more effectively, more efficiently, with far more options that a senior engineer then will look at. So we have to look at it not just in the context of how we teach, how we learn, but also how we do research and how we prepare our students for the future. If you look at it in terms of research, excuse me, and in terms of the development scheme, again, we basically say that AI is going to change things dramatically, that it can have a tremendous effect, not just in research, but in the application of research to the real world, whether it is speeding up interactive systems, changing things in terms of water security, changing building design, or even looking at manufacturing. So one has to accept that we are actually changing the way in which we not only work at a university, but it's actually already changed outside in the workplace in terms how AI platforms and AI programs are increasingly become part of the ethos and the environment. So if we come back to the university, then let's look at it from a standpoint of an evolution in the creation and the dissemination of knowledge. If you go back centuries, we had Socrates, Plato, the learned sage, if you will, who held stage by having some of the students around him. At that point in time, most of the faculty were male, but there were a number of female, let's say, pioneers at that time as well. Writing was on scrolls. They were shared in a few libraries and was only accessible to a few people. We come upon the Gutenberg press, and that changed things significantly. Knowledge was shared widely with a lot of people because of the ability to have things printed. Obviously, at that point in time, just as we're going through today, the Gutenberg press was supposed to be the end of all humanity as we knew it and the end of all learning because it would change the way we did it. But we moved from there to textbooks. We moved from there to large classrooms. We even had the lonely faculty member, but with access to a lot of knowledge, being able to write a book and then share it with the rest of the world. We moved from there to the use of multimedia in classrooms and the use of the web so that we could actually share knowledge from across the world and bring people together. We did a lot of work on online education prior to COVID, but COVID accelerated it completely, and we saw ourselves moving from a geographically co-located sense of learning and teaching to something that was now spread across the globe. We were simultaneously looking at ways where we could interact with the rest of the globe in terms of research. In fact, we'd already been doing it under some of the large projects funded by NSF, where we could have large laboratories, such as the laboratory at UCSD where I was, where you could run a very large structural test, but the control could be from another part of the country with the person who was actually running the test. But that changes the way that we were looking at it, and today we're looking at it in a totally different framework. So we need to ask ourselves two questions. Can and should we be shifting from bringing students to campus to enabling learners to access knowledge where they are? That obviously changes the entire concept of a university from being a physical entity to being a phygital entity, which is a mix between digital and physical, where you can gain knowledge in the form that you want it, when you want it, as you want it, and at any time that you want it. And should we also be shifting? Can we shift? We've already made the change, but it's a question I'm going to pose right up front. A shift from the isolated researcher or team to truly collaborative discovery, including human-machine interaction, where not only interacting between groups of humans, but the machine becomes part of that interaction and collaboration. So I'd like to run through a number of scenarios. I'll start off with engagement and learning, and I'll go deeper into the research enterprise. But if you look at it from this, AI already enhances engagement and learning. We've all heard about the AI personalized tutor, and it is absolutely true. If you look at personalized tutoring that is done the right way, not just adaptive learning, but truly personalized tutoring that is available 24/7 with all the background material that is possible, it is extremely, extremely helpful to a student. But we also know that when we actually learn about something, the best way to show that we have learned it and to organize our own thoughts is to be able to share that knowledge with somebody else. In fact, most of us, when we became faculty, found out that the first time we walked into class, we found that our knowledge was not as good as we thought it was because we now had to explain it to somebody else. That concept of a study buddy can actually be done with AI, where we're explaining it to get clarity with an AI platform and therefore learning things ourselves. AI can also help in terms of organization of data. And I don't just mean in terms of vast amounts of data as we do in research, but when we put together our class notes, they are generally in an absolute mess. At least that's the way it was when I was a student. With AI, you can actually put them together and get notes from there. You can actually test yourself, you can prepare yourself, and you can have a lot of excessive knowledge that can be brought to the field in order to help your learning. Obviously, immersive learning is a totally different concept that we need to look at. One of the biggest critiques and criticisms, if you will, of AI platforms is that it'll take away the ability for a person to do critical thinking. I'm of the opinion that it is actually completely different. We don't teach critical thinking extremely well. We just expect it to occur in our, let's say, classrooms. But think about the power of actually taking immersive learning, where you have AI coupled with AR, VR, and XR, and we put the student into the actual environment into which we are expecting them to learn. Whether it is Pompeii and Vesuvius and what happens, or it was the barge that hit the bridge in, let's say, Baltimore in the harbor. And as a civil engineer, I wanted to know why is it that that actually failed? Or if you look at the crash of the Air India jet, as to what could have happened and learning from that, not in terms of forensics so much, but learning from it for our students, that is now actually possible. Think of the socio-cultural implications for our students being immersed in something that was only possible before through a very focused study abroad, which is not possible for everybody. Immersive learning takes on an entirely different format, an entirely different concept, and critical thinking becomes automatically available to our students because we can put them into that. We had, for example, years ago, a lot of simulations that were built for our nuclear engineering programs where we couldn't afford to have a nuclear reactor on campus, but we needed our students to go through the training, so we did it for that. Today, it is possible now for that to be done across the field. And think about the power of a student learning how to actually design a gas turbine engine or something else for an aircraft, or looking at different aerofoils, not just in terms of concept, not just in terms of doing a single equation, but playing the what if games and actually seeing what comes out of that. With AI, it's not only possible to imagine, but it's also possible to play that what if that causes us to learn so much more. We have so many students who come into our colleges and universities not knowing exactly what they want to do. And we do them a disservice by saying, you should be a mechanical engineer, or you should be a philosopher, or you should be an English major, when we haven't given them the ability to actually explore the careers. AI gives us that possibility to not only explore the careers, but put themselves into that mode. If I were to live a day as an electrical engineer in the field, what would I be doing? What are the stresses that I would actually face? We do that in terms of medicine and nursing, where our nursing students are actually, as part of their training, they actually go through an actual experience, so multiple experiences, not just with anthropomorphic dummies, but also putting them into a VR environment where they see what happens when a patient actually redlines and dies, so that they understand the stress. And our nursing schools have done that for years. We haven't done that in the rest of our disciplines. We now have that ability to give career experiences to all our students. We would all like for our students to have advisors when they need, but the reality is, with the numbers of students and the numbers of advisors, whether they be faculty or they be staff, our advising is with a long backlog. A student who needs information at 2 o'clock at night as to which course to take or whether they should do A or B can actually get that from an AI tool or platform, as long as we take the time to fill it in properly. And that can be significantly, let's say, helpful to them. Expert engagement is another area where I'd like us to imagine things. It's being used, but perhaps not being used as much as it should be. We know, for example, that some of the best experiences that we have gained, some of the best learning that we have been able to do, is to basically talk to the expert and learn from the expert by having a dialogue with the expert. Very few of us have had the ability to do that with real experts, whether it is having a conversation with Mahatma Gandhi and Martin Luther King about nonviolence and what their philosophies would have been in certain areas, or in my case, with actual bridge designers or aircraft designers. If I were to bring in the Sikorsky, and I would bring in Ilyushin, and I would bring in somebody else, and to see if they were to work together, how would they have designed a plane? Well, we can do that now. And some of us are already doing it to actually give students that experience of having a conversation with a set of experts, as long as, of course, we control where that information comes from. Google is obviously garbage in, garbage out, but as long as we have validated knowledge that we are providing, we can have some wonderful experiences. And I'd encourage each of you to try to do that. Try to go into even ChatGPT if you want, under the free version, and say, I would like to have a conversation with ABC about the topic it's XYZ. Use only validated forms of information. Obviously, the prompt has to be more detailed. And I would like to discuss with that person or persons the following topic. You'd be surprised as to the depth of information that comes and how much we learn from having that conversation, and how much more we can actually tighten our understanding of the topic because we have to explain the topic. And obviously, we can do the same thing with enhanced learning, where we can play the what if games and truly allow for discovery and project-based learning through the use of AI. Excuse me. This changes everything substantially. It changes from just a student being able to look at a single topic, a single equation, and having to imagine how that equation translates itself into the real world or into the world of the future, with actual simulations that allow them to be part of it, allow them to look at multiple options at the same time, and even looking at the end result. It takes us from a lab where we could do some things to labs where we could synthesize artificially and in the virtual world what the results would be, thereby allowing us to do things that otherwise we might not have been able to do, from concerns of safety or from concerns of resources and expense. Now, obviously, when I say safety, I'm not talking about going beyond the bounds of ethical and moral behavior. I'm talking about things blowing up, or things that happen because we are not able to control them in our labs. Let's move from that for a few minutes now, from our learning to our research abilities. So if you look at our research abilities, AI can completely change our research abilities. And I'm not talking about the use of AI to do research. I'm actually talking about AI as an enhancer of the research that we do. We can talk about it in terms of AI as a research assistant, and I don't mean only for the faculty. I also mean it for the PhD or the master's students, or for that matter, for an undergraduate researcher. And AI as an interpreter, a thought partner. I'm sure the faculty all have had the critic or the reviewer too, and I'll go into that a little bit more. A simulator, a synthesizer, and a communicator. But let's start with AI enhancing research abilities as a research assistant. An AI platform that is actually programmed the right way can integrate and analyze far more data and scan across different data sets far faster than the human can. Therefore, it can see trends that we can then go back and validate in a much shorter period of time. It can conduct 50 or 60 simulations in the same time, or maybe much faster than we could conduct one. And therefore, tedious and repetitious work that needs to be done. I'm sure our graduate students will basically, let's say, understand and recognize when a faculty member gave them a set of data and then 2 days later said, do the same thing with this data. Now do the same thing with this data. Now do the same thing with this data. And at the end, we put those final results together. It was like, I've done it once. It's a process. Couldn't it be faster? And obviously, we had programs to make it faster. But think about AI being able to do that. Do things beyond the learning by human assistance. Once we've learned it, we're wasting time. But AI can also derive connections, trends, and insights. It can consider far more options in the same period of time. Greater ability to try concepts that may lead to dead ends. So many of us will try a concept and say, I don't think it's going to go far enough. And therefore, we don't pursue it, or we don't give it to a PhD student because we're not sure it's going to lead to a degree in time. A lot of that could actually be tried out with AI, and it presents us options at each decision level. Keep in mind, human agency is still important. So when we're using AI, I'm not saying replace the research assistant. Let the research assistant enhance what they're doing with the use of AI. Let's talk about AI as an interpreter. AI can actually translate from multiple languages. And I don't just mean languages in terms of German and French and Chinese and English and Hindi. I actually mean languages also between different disciplines. So often we talk to, let's say, researchers in another discipline. We're using the same words, but we're not able to understand each other because the context of that word is different. And this not only exists when we are between engineers and scientists, or engineers and people from the humanities, but between engineers and engineers. When we talk about something in the aerospace world and the civil world, which is the two worlds that I go back and forth in, I actually find that we talk about the same terms with very different meanings. AI can help fill that gap. It can also provide context from multiple fields, including language. I'm sorry, is there a question, or is that just background noise? Sounds fine. I'm going to assume it's background noise, and if it's a question, we'll hold it till the end. It can also connect the dots between those fields and disciplines. It can disaggregate data and trends into patterns and interpret those patterns for us. And obviously, because of the ability to interpret and communicate, it can actually help us do more effective work by multi and transdisciplinary teams. Just as the same as we talked about a study buddy for our students, AI and research can help being a thought partner. So often what we wanted to do is to call someone up in the middle of the night because I'm working on a research paper and I want to ask their opinion on whether this idea was right or wrong. I don't want to have a long conversation. I want a thought partner. I want a sounding block. I want something over which I can throw my ideas and get feedback. And AI actually works extremely well with doing that, as long as, again, we have constrained where it gets its knowledge from. It assists significantly in brainstorming. It can help in identifying blind spots, avoiding pitfalls, and testing out strategies that we come up with. Debate and debating partners for looking at hypotheses is very important in scientific research. And AI can help us actually argue with ourselves. And it can come up with asking critical questions for us to consider as we do research. Remember, on all these things, I'm not saying let AI do the research for you. I'm saying use AI in order to actually build on the research that we're doing, fine-tuning the arguments and checking the rationale for it. Is there a critical flaw in what I've presented? Is there a gap in something that I have done? Should I have considered something else? The answers may be right or wrong, but if we're truly going to be the experts in it, we'll be able to take that gem of knowledge and then use it and help us in developing strategy and focus parts. Those of us who write papers, we've all seen that infamous reviewer 2. Reviewer number 1 writes, "This is a great paper, accept it." Reviewer number 3 says, "Good paper, just make some minor changes." And reviewer 2 trashes the paper or the report or the book that we have written. Or for a student, it's the faculty member who unfortunately looks at your entire work only in 5 days before you're going to defend and finds 1,700 mistakes in it, which they should have found earlier and helped you out. AI can actually be that critic and reviewer, pinpointing potential errors in logic and approach, identifying holes and flaws in the arguments that we're making, and critiquing graphs. I'm not saying use AI to write the graph for you. I'm saying use AI to critique what you have written and find the holes in it. Find where the logic does not actually hold. Find where you haven't explained things enough. Compare your work to prior work to ensure that we're actually progressing rather than going into repetition. AI is wonderfully great if you use the right AI tools. Keep in mind, ChatGPT and Claude are not the response for everything. They are very specific tools that can be used for actual review of literature and comparing that literature to what you've done. Similarly, in terms of simulation and synthesis, complete complex analysis with multiple what-if scenarios. We generally run 1 or 2 scenarios, and then we say, we hypothesize that since it's worked with these, it will work with everything else. Because we don't have the time to actually check it, neither do we have the ability to do that. But with AI tools and with machine learning, we can do that significantly faster and conduct data analysis on different streams of data at the same time, assessing trends and insights that we then use for our research. We can visualize results and scenarios to check the validity and the viability of the work we're doing. Just because an equation is valid doesn't mean that the end result is going to be viable in the field. We've seen so many things that we've designed that cannot be manufactured, and therefore we have to be able to look at them both. It can generate hypotheses and questions based on patterns and trends and allow the student, the researcher, to be able to simulate and go forward. It can also serve extremely well as a communicator. Obviously, at the first level, it checks and assists with grammar and the use of languages. And this is what I find the most funny. There's this big outpour about why are we using AI and it's completely changed everything. Well, we've had spell check for years and years, and we've all used it almost automatically. That's the form of AI, and we accepted that. So we need to keep in mind that a lot of things that we said were not AI were actually AI and were available 10 years ago. It's just that ChatGPT with LLMs changed the way in which we interact and the way we ourselves can create these models and create these platforms that has changed our outlook on it. It can help translate what we're doing into different languages. It can help modify our approach, just as I said before, based on the disciplinary context in which we are working. Most of us as faculty, most of us as researchers are not very good at communicating what we do to the general public. We tend to go at such a high scientific level into so much depth that the actual core of what we've done is totally lost by the time we share it with the public, which is one of the biggest problems that academia has today, that it has not been able to convey the value of what we do because we're not able to communicate in the right language, whether it is for science or it is for just what we do at the university. Focusing that communication for intended audiences is so very important. And yes, that could be done through a complete marketing and communications team, or it could be done through the use of AI. Just as you've seen, it assists in developing graphics and images, as long as I'm able to tell and prompt exactly what I want from the image itself. Multiple representations to see how it could be represented so that it comes across not only to the audience, but it also exactly shows what I wanted to show, and creating summaries and abstracts from very long papers and very long reports to being able to tell us what is the core and the gist of what we have already done. One of the biggest challenges is in updating documents and reports. We tend to have new reports, but we don't update them with everything that we have done. And therefore, we will find that we have a set of standards that reference things, but the standards themselves have not changed in terms of the numbers, the documents, and everything else. AI can do that extremely well. If we say that, yes, that is something that we want to do, we still have to keep in mind that there are concerns with academic integrity. And I'm going to be fairly blasé about quote unquote cheating by students. Cheating has always taken place. AI has just brought our recognition to the fact that it takes place. It might have democratized cheating more than anything else. So I'm going to say that is a concern that we need to deal with. We should have dealt with 20 years ago, 40 years ago, 60 years ago through changes in our assessment. Let's not focus on that and say that is the reason why we shouldn't use AI. Because one of the bigger problems that we have is academic integrity from our own faculty and from researchers across the world, where we have AI being used to not only help in writing papers, but that actually writes papers. Here's an example of a paper that was written in Surfaces and Interfaces and was published. And if you look at the first line in the introduction, certainly here is a possible introduction for your topic. What does that tell us? That whoever wrote this paper basically used an AI platform in order to put together the introduction. It also tells us that whoever reviewed the paper probably did not review it and just wrote some cursory remarks. It also tells us that the editors did not look at it and allowed it to go forward for publication. And that is the academic integrity that we should be worried about, because that is archival literature that is going to go forward. And I just used one where it is just the use of AI. Think about where there's wrong information in it. Think about where the research is flawed and it is going forward. So when we talk about AI, let's talk a little about concerns and challenges. From the research perspective, there are concerns that we need to keep in mind in terms of research integrity. Whether we're doing the research the right way or whether we're using AI without any check on the quality and the accuracy. Are we creating synthetic data to fill the gaps in the actual data that we have, and therefore drawing conclusions that may or may not be correct? We know that for certain mathematical tools, we need a smooth set of data in order to run that tool. And we may only have 2 to 3 points. Previously, what we would have done would we would have gone back and run more experiments to fill those points. Today, a lot of researchers are using synthetic data to fill it without knowing whether that trend is actually linear or otherwise between those points, giving us a lack of quality, a lack of accuracy, and obviously the lack of research integrity going far beyond how a paper is written. Bias and fairness that comes from the use of data or the existence of data and how we're projecting the data for the conclusions of our research is something that we should be looking at very, very clearly. When we look at futuristic potential, when we look at scenarios that come from the future, but we use data sets that are biased because of the way they were collected in the past, then we have a huge problem in terms of our research itself. We obviously have big concerns, or we should have big concerns, where if a person has over-dependence on AI, you can have the erosion of skills. I'm all for people doing a lot of what-ifs using simulations. But if they don't know how to use the actual laboratory, or if a designer doesn't know how to do a back of the envelope calculation, we are going to have disasters at the end. And therefore, that overdependence, not giving these students, not giving our researchers the foundational skills, and depending only on AI has a big problem and a big concern and challenge. Privacy and data protection is of great, great concern. Because we have these vast troves of data, are we going to be using the data for the reason why we actually collected it? Or is it going to be used for something else? It's not only data in the medical field, where, for example, we collected data on the health effects of smoking, and then that data was used by insurance companies to either give insurance or not. But it could also be in terms of how we use rainfall data, how we use data on buildings, and how we use data for the planning of cities, and how that affects the people who actually live there and the people who will be living there in the future. And then we come to a topic that we need to discuss and grapple with and come to some terms with. What is IP and what is copyright? When we can actually create, disseminate, and come up with new knowledge based on the sum culmination and synthesis of knowledge that already exists. The easiest way that we sort of have to talk about an analog is to say, if I took a Leonardo da Vinci's painting and then I used AI to modify it, is that my art or is that somebody else's art? If I used all the knowledge that exists from scraping millions of documents and I wrote a new screenplay from it, is that screenplay mine or do I owe royalties to everyone else from whom I took it? These are things we've heard about, but what we need to consider now is the effect of that on science and engineering and research. If I were to scrape all the data as I do, and then I come up with a new hypothesis based on a hypothesis that was partially created by somebody else, whose hypothesis is it? Mine, or shared between AI and me, or shared between the originators of that and me? What is the value of a patent if I can walk around the patent in 5 seconds because I can use AI to create a legalistic framework? What does copyright mean when tomorrow I can actually see my own work being used by AI to create another document by somebody else? We worry about our students doing it. What we should be worried about is what we are doing ourselves. If we are using AI to help write a paper, AI has scraped, or we have scraped through the platforms, knowledge from a lot of others. We're incorporating that in our papers. I'm not saying it's right or wrong. I'm not drawing any moral conclusions from it. I'm saying we have to come to terms to what all these terms that we were so comfortable with, what does that mean? Is knowledge now collective or is knowledge individual? When we do research with AI as a collaborator, who does that belong to? And where is it morally, ethically, and legally? So when we look at AI and we look at the ethical concerns related to the use of AI, we have to go far beyond the general things that most people have talked about. These are the concerns that the general public has been talking about. But when you overlay it with science and research and it's engineering, we have to be involved far more. Inherent biases of the data on which the AI is trained. We've always been worried about what happens to people, but what happens to our own research when it is trained on data that is no longer valid for the types of machinery that we're going to be using in the future, or the types of science that we're going to be doing in the future? What if we're using a historical context that no longer fits for manufacturing? It's a predictive tool and therefore it extrapolates. How do we make sure that the extrapolation is not going to cause problems? From a science and research point of view, a black box is the most dangerous thing that we can have. I know that there are legal implications, and a lot of people think about black boxes when we talk about decisions. But what about in science when we use a black box to take a decision as to which way to go or which of the options is the best? Garbage in, garbage out is something that we have to keep in mind. We have to look at the ethical imperatives, the consequences of AI decisions for students, educators, and society, ethical issues in algorithms and data, fairness, transparency, and explainability. Can we, at the end of our research project where we've used AI, explain every step of what we've done? For those of us who've used machine learning, we've already come up with this as a problem. When we come up and say that we are using a form of regression and we're using a best fit, can we actually walk through the steps and know exactly how that fit was done so that it could be duplicated the next time when our data sets are very large? And therefore, we have to look at ethics and accountability from a research perspective. A perspective in terms of our bias in training data, in algorithms and output, in prioritizing accessibility and inclusivity, not just in terms of researchers, but also in terms of where the researchers actually exist, ensuring that the tools do not perpetuate or create new bias. Transparency. Just as I started this, it's a presentation and said, I used AI in order to actually, build some of the images. We should be, acknowledging when we use AI for any part of the research for which we are doing, the data that it was trained on, so that we can identify and mitigate bias. We have to be able to trace that. We always said that when we had data, our lab notebooks, we were able to trace the data, or at least we should have been able to. When we use AI tools and we use a large amount of machine learning and we use neural networks and we use even more complex agentic AI tools, are we as researchers sure that we can actually trace and explain the conclusions that we have made? Are we keeping human agency in the end, that even if we've done 50 different simulations and we choose one as being the right path to go forward, that we as the researcher can actually pinpoint which one and why, and that we have a chain of responsibility? How robust is our research environment when we're using these tools? We've all talked about the digital divide, and we saw the effects of the digital divide when we had COVID. We expected everyone had a computer. We expected everyone had broadband access, and we found out they don't. But think about it one further in terms of the AI divide, which magnifies the digital divide significantly. And how do we make sure that it remains relevant for our students who are going to be entering a fast-changing world in which they are going to live and work? So when we talk about AI, we should be thinking about 4 levels. The first is the simplistic one: access to technology and tools. We'd like to have AI platforms to do research. We'd like to have AI platforms that help with our learning. We'd like to have tutors. That's great. It's the second one that starts becoming worrying even today. We may have the tool, but do we have the expertise to use it and the expertise to explain how it is going to be used and how other people can use it? The third one, beyond just the use of the tool, can we actually develop AI literacy? And AI literacy is not just, can I use it, but do I know the implications of the use rather than a black box? Can I analyze? Can I develop? Can I create? Can I use data governance in my research? Can I have an elevated level of agency? And then obviously, how do I bring it back with traceability, explainability, and transparency so that it leads to equity and socioeconomic mobility for all students and learners, and with the bias that we're going to build? And remember, this is not just a social construct. It is a research construct that we have to think about. How do we create AI that has seatbelts, brakes, and airbags while we're doing our research? Not just for our students, but even for ourselves. AI, if we're to use it correctly, then we're going to have to make some changes with the way that we do things. We're going to have to transform the way we think about it. We've always talked about EdTech. Use a program, use a platform, digitize the university, including our research. But really what we need to do is now look at tech ed. How are we going to use technology to re-envision the organizational structure, the function, and the focus? Not just for extreme personalization, but also flexibility, and making it focused on the learner rather than the institution. How do we move from teaching to learning through discovery and inquiry? We've always talked about discovery and inquiry, and I know that Farokh has done a lot of pioneering work in that, including making it possible in terms of entrepreneurship and innovation. But how do we do that across the board? How do we work? And these are the two important points to look at. How do we move from teaching based on a fixed body of knowledge to a collaborative learning where human and machine continuously build on together, where the knowledge now is changing significantly across the board? And how do we move from the university as the controller to the enabler, to the enhancer, an integrator at the systems level, using data and trends to constantly improve and reinvent itself? I'll leave with two thoughts. AI is a tool, it's a program, it is not a person. We make our biggest mistakes when we actually anthropomorphize it and say, AI made the mistake. No, AI did not. We did. Human agency is critical, especially in research, for the ethical and responsible use of AI. And at the end, we have to ask ourselves the question, will AI be transformative in enabling advances in learning, research, and socioeconomic mobility? Or if we don't pay attention, will it just be another technology that further widens the digital divide and disparities? That choice is up to us. That choice is not just with the politicians, it's with faculty, students, researchers as to how we go forward. With that, I'll end. I hope I gave you enough to think about. I hope I've given you more questions than answers, because I look at my role as being the kickoff speaker and asking questions and setting the stage. So with that, let me stop. And then if there are questions in this time, I would be glad to answer them.
Thank you, Professor Vista. Thank you for this thought-provoking uh, talk. Now we are open to questions if anyone has any questions.
Please put your question in the chat or just raise your hand and ask the question to Vistasp.
Unless I put everyone to sleep.
I want to start with the question.
This is Rustam.
It's Pejman.
Please.
Can you hear me? Yes. I want to start with it. It was a great presentation, especially kind of helping us to better understand how AI can be used and kind of what would the places we shouldn't use it or we should be careful. Especially I'm kind of teaching the courses, especially undergraduate courses that are fundamental courses, and I'm trying to use AI. I want to see what would your idea about kind of using AI, what would be maybe your suggestion, if you have any comments that can help, especially bringing AI to undergraduate courses, especially fundamental courses, would be great. I would like to hear your idea.
So I think they can be used in a variety of different ways. I mean, we obviously have to engage with an AI platform in a way that changes the way we want our students to think and we want our students to learn. So let's take, for example, one of the ways that we've always found that is great for learning is to ask a student to grade somebody else's work or to grade their own work and make modifications to it. It is actually fairly easy to put together a problem where we know AI is going to make a mistake. The AI platform is going to make a mistake. Allow students to actually solve homework problems using AI, where it's going to make a mistake, and for the student to pinpoint where the mistake was made, use their prompts based on their knowledge to then guide AI towards the right answer. Keep in mind what we're doing is reinforcing learning, because what we're doing over there is we're saying, okay, you have to know where the mistake was made, then you have to know how to guide it, just as we would with another student helping another student in terms of what to do. The other thing is when we solve a problem, we basically tell them, for example, let's look at the analysis of a single beam. We talk about a beam with a point load that has a span of a certain amount, and we say, what are the reactions? What if we said, okay, we had a point load, now let's get an equivalent triangular load, or if we had a sinusoidal load, and we allow the student in order to play the what if games. What if we said that the beam was not just a rectangular beam, but was actually it's a prismatic beam with a change in cross section? Those are things that can be done on a routine basis with AI as we're learning about it. What if we could actually take a student and take that student through an actual building or a plane to show them the effect of what they're doing on the plane or on the building so that they can learn from themselves, if I made a mistake, what are the effects of that mistake? So there are a huge number of ways in which, even at the very fundamental level, we can use AI to increase the ability to learn. Keep in mind, we're so used to teaching that we've always said, I'm going to tell you something, you repeat it, and magically we've learned it. All we've done is we've reinforced, if you remember what I taught you, then you can solve that one problem. I changed the wording a little bit, and the students out at sea. This is where they could do a lot more.
Thank you so much. Great suggestion.
Dr.
Thank
Karan?
you, Dr. Pejam. Yeah, Dr. Zareen.
I'm sorry.
No, yeah. Dr. Zareen, you have a question?
Yes, thank you very much for the general overview and points of caution and guidelines. But could you tell us a little more about, you've said don't use ChatGPT, for example, to review your work. Can you give us some suggestions about what we use for what and
Sure.
what
And I
you
mean, keep in mind,
recommend?
absolutely. So, for
Thank you.
example, let's start out with ChatGPT. The problem, first of all, is most of us tend to use the free version. I don't, I use a paid version. Anything that you use in a free version of any AI platform, that AI platform is basically using your data and sharing it with the rest of the world. Therefore, if you put in something on which you're writing a paper or a book, tomorrow, somebody who has asked the same prompt is going to get that entire information and can actually publish it before you
That's
do.
right.
Or
Yes.
worse than that, if you put in wrong data, the wrong data is now going to live in itself and become far more than what you thought it
Right.
was. That's the first problem. The
Right.
second is that each of these platforms have been built on data from different data sets. And therefore, if we're trying to do work in engineering, or if we're trying to do work in science, or if we're trying even to do a literature review, just using ChatGPT is not enough. We need to use specialized AI tools that are focused on that area. So you will actually find that if you use ChatGPT to do a literature review, you're likely to get a large number of hallucinations. Whereas if you use a literature review tool that is very specific to literature review, that is linked to our actual databases, you'll get a far better one. So that's what I meant
How
when
do we find that?
actually going through the same way as we would somewhere else and finding out what other people are using and looking at differences or trying it out yourself. Unfortunately, we have new tools being put up every day. Therefore, there isn't one resource where you can come and say the best for XYZ. Also, what is happening is every week, a tool that was not as good is now becoming better because the people who are working on those tools keep adding more features to it.
Yes.
I'm sorry, there
Thank
isn't a very cut and dried answer to this one. But the answer is that if we're not careful, we're probably using the wrong tool because we find it just the most convenient.
Thank you.
Thank you, Dr. Zareen, for the question. Rustam, you do have a question? No. Okay, then we can move. Mr. Edul, do you have a question?
No, not really. No, but thanks, Vispas, for a wonderful overview, a very thorough AI overview, and certainly it offers fantastic opportunities for the betterment of mankind. At this stage, it's beyond my job grade, if you want to call it. And I think what we hear, we have to move from talk AI to do AI to really get a good understanding of what it can do. So for the researchers and the students, you have to get your hands wet and work on it. And
Absolutely.
Yeah.
I mean, it is fascinating to see when I actually talk to other faculty, when I'll give them an example of what I'm doing, it will be as though it's like, oh my gosh, you can do that. And what I'm doing is very simplistic because AI affords us its ability to enhance what we're doing as long as we know what we're asking for. And as long as we can put those boundaries around the type of knowledge that we're trying to bring in, we have to be very careful about what data we're using and where it's been scraped from. It's again, garbage in, garbage out. Those of us
Right.
who basically saw finite element analysis when it first began, people used finite element analysis and they basically said, I'm sure you remember, Farokh, where people came up with the deformation of a beam that was much bigger than the span, and everyone said, wow, it must be correct because FEA gave it to us. We forgot our fundamentals.
We have a question in the chat from Percy. When do you think
When do
AI
you
will be
think AI
taught
will be
in
taught in schools, middle and high?
schools?
I think it's already being done. In fact, there are a large number of schools where the use of AI is part of it. We at universities are actually behind the times. We are not using AI as much as some of the advanced schools are across the nation, and especially in some other places, including China.
Maybe I'll go back to school and learn some.
No, but this is where we tend to follow one of three modes in academia, unfortunately. There are those of us who say we will not do it because anything new is bad.
Any change.
There are those of who put our heads into the sand and say this will pass us by, and therefore, if we just keep quiet, we don't have to worry about it. And there's a smaller number who basically say, okay, this is something that maybe I can be part of. And this is where we need our faculty and our students to actually be part of this. Unfortunately, what has happened is we've allowed big companies to tell us how to use AI rather than saying AI exists. I mean, keep in mind, AI was being used at the universities 20 or 30 years ago, but it was being used in a very, very controlled way because programming was very difficult. With the LLMs, it has now become used widely, and what we have stopped doing is trying to figure out how it is best used within a university setting, how it can be best used by research and in terms of its development and in terms of in the actual workplace. We need to be leading that, and we've basically given up on it so far. The more our faculty and the more our graduate students can be involved with playing that game and saying this is how it should be done, the better off we will be.
Thank you.
Thank you, Percy, for the question. We have another question in the chat from Buji. I'm sincerely worried about the vicious circle of the use of LLM, given that it is trained on the already existing data.
And I would agree, except for one thing. Most of the work that we do is based on existing data. Most of the decisions we take, most of our perceptions are based on existing data. The reason why it's not a problem is we use human agency to figure out whether it is right or not, moral or not, ethical or not, correct or not. With the use of LLM, we need to still maintain that agency. Remember, it is not a person, it is a program. We tend to think about it as a person because we're able to, quote unquote, talk with it, and it seems to respond to us. It's not responding to us, it's responding because it was programmed to respond in a certain way. Now, AI in 5 years or 10 years might take on a totally different, say, field. But the AI that we're dealing with today, at least most of us, are LLMs. Mary had a little blank. It is the probability of the next word that is the way that AI works today in LLMs. And we should remember that. And therefore, when we worry about past data, it's the same as the past data that we tend to use every day. Only we use human agency. So I'd encourage us to keep that in mind with the use of AI. At the end of the day, we still have to decide whether it was based on data that makes sense and whether the results make sense or not. Not just, I would have done this in 6 months, it's given to me in 2 days, now let's write a paper. Perhaps we should be spending a week to a month looking over all of that and replicating it to see whether it is right or not. And you'll actually find that sometimes it's wrong. But in being able to give you a trend, it has given you a jump in terms of what you could have done with your research.
Thank you, Uchi, for the question. Does anyone have any other questions?
So I'd like to share with you what the rest of the semester is going to look like. On September the 18th, we have Naveen Kumar from the Price College of Business, and he's going to talk about agentic AI, opportunities and challenges in information management. On September the 24th, it's Jiadong Chen. He's going to talk about building high-resolution storms with generative AI. And then on October the 2nd, we have Kayan Mistry, who's going to talk about generative AI from data to decisions. He's put together a platform. He's put together a platform company that has just made a huge splash in London using these LLMs to pull the business plan together and to pull the data together from all over the world. Vishal Singh, who's well known in India, he's going to talk about generative AI and LLMs. He's posing the question, are generative AI and LLMs reshaping human-computer interface? Dan Fisher and Haotran Liu are going to address the question, will AI make or break engineering careers? On October the 30th, we have a professor from the Department of Classics and Letters. Her background is in religious studies, and she poses the question, ethical AI, what do we gain, what do we lose? Iman Gamanian will be talking about demystifying generative AI in 45 minutes. Jitesh Panchal, who's an extremely well-known figure in the academic community from mechanical engineering, he's going to be talking about design of AI-enabled systems to research on opportunities. Then we have Eric Day from the Department of Psychology, who is going to touch upon it from a work psychology view of AI's potential. So we have it from the business side, from the academic side, from the industry side, from the psychology side, from the philosophical side, from the ethical side. We have people addressing various aspects of generative AI this semester. So with that, I'm going to stop the recording, as is our